Okay, hi again. So I'm making another video. Today, this is kind of a more algebra-based video, kind of making sure you know how to convert bases of exponents. So let's say we have some exponent a to the b, and we want to get that equivalent. We want to get the exponents equivalent, and we have some number c to the d. So we want to figure out a way to get b to d. Well, what do we know? So we know that you can reduce the base by squaring the number, and that number becomes the base. Like, not necessarily squaring, but raising that number to the power and then reducing this power by that. So let's say it's kind of a hard thing to arbitrarily explain, but let's say we have some number 2 to the 8, and we have 16 to the fourth power. Well, if we want to get this to the same base so that we can do things the same thing. So let's say our goal is, for example, to multiply them. We can only do that if the bases are the same. So 2 to the 8 is just going to be 16 because 16 squared. How did I get that? What's 16 in terms of 2? As 2 as a base. Because I need to get 16 as my base. So I'm going to plop 16 here just to start, okay? 16 now in terms of 2 is 2 to the 4. Now, since I'm making my base 2 to the 4, I only have a factor of 2 in the exponent that I need to account for. So that means that I only have to raise my base now to the second power. So then I'm really going to be multiplying 16 squared times 16 to the 4th, which is going to be equal to 16 to the 6th. I know, it looks complicated, but it's not, okay? This really comes with practice. So let's say we have some equation. X equals 3 to the 7th times um, 3 to the, or let's say 9 to the 4th. And let's actually make this a cleaner number so it's easier to show. Let's make this 3 to the 6th. So if we want to show if we want to find x, instead of having to multiply each number out and plugging in your calculator, if you just want to be able to do this by hand without having to multiply these numbers and get some big long number and put it in terms of some number, the larger base in most cases. So what we can do here is we know that, okay, we want to get, let's start by trying to get in terms of the base of 9. You can go both ways. You can try to get everything in terms of base 3 or base 9. So let's say we're trying to get in base 9. So we're going to have to make this base 9. And we're making this base 9 too, okay? So nothing changes on the right here. But since we're making this base 9, that's really 3 squared. What's 6 divided by 2? It's 3. So what we have to do here is raise this to the third power, because this is the base now. This is the same thing as this. This becomes the base, and then now we have to raise this to the exponent. See what I'm saying? So now this would just be 9 to the cubed times 9 to the 4th, which would be 9 to the 7th. Works out nicely. Sorry, I'll hide that. So now, what if we wanted to do it so that we got everything in base 3? So let's say we have 3 to the 6th times 9 to the 4th. So it would be x equals 3 to the 6th. And then, so this one always stays the same, whatever base you have it in. Then okay, this is going backwards, so it's a little different. So we know that 9 is 3 squared. Since we're going to be writing in base 3 now, we have to make the exponent bigger to account for the shift in base. So since it's the exponent of that is being divided by a factor of 2, we multiply the new exponent by a factor of 2. So it actually becomes 3 to the 8th. So we multiply this by 2 since we halved it to get from here to here. And so now this becomes x equals 3 to the 14th. And let's say now we have our two solutions. Okay, we have 9 to the 7th and 3 to the 14th. And let's say we want to put these in terms of the same base. Well, let's put 9 in terms of 3. Well, here we go again. We have 3 squared to the 7th. Since this is a power, however you want to say it, we multiply these. So we get 3 to the 14th and 3 to the 14th. These are equal. It works any way you do it. It's just by, you can kind of think, it's kind of like PEMDAS, but a little more difficult because you have to follow more steps and you kind of have to know the laws of exponents. So let's try to do this for something that is maybe not as easy. Let's say we have some number 27 cubed and 3 to the 6th. Okay, so we know that 27 is equal to 3 cubed. So this becomes 3 cubed cubed. And we know that this is 3 cubed squared. Do you see how I got that? Because 6 is 3 times 2. So I put it inside of the base, and then I put the exponent on the outside. That's a totally viable thing you can do. So now what do we have here? Well, I'm going to put this as 27 again. So it becomes 27 times to the 5th power, because we're multiplying this. Let's just say we're multiplying this. I know I didn't state that at first. But what if we wanted to solve this a different way? What if your teacher asks for the answer in terms of base 3? Well, instead what we can do here is, why don't we just keep the base looking like 3 to the 3rd? Well, what we're going to do here, same thing. We just add the exponents. We get 3 to the cubed to the 5th. And since we multiply these exponents, we get 3 to the 15th. Well, wouldn't you know, these are the exact same thing. This is 3 cubed to the 5th, which is 27 fifths, or 27 to the 5th. They're the exact same thing. It'll always work out every single time. You just have to practice and play around, and you have to, what I honestly recommend is, instead of trying to make the base larger, try to make it smaller, because it kind of it makes it easier to look at and perceive. So yeah, any questions, again, just ask me in the comments and I'll be sure to answer. Thank you for watching. Appreciate it. Have a good day.